Welcome back. In the last section, section 2.2, we did a lot of work on isomorphism, on kernel, on images, on relationship between basis of one's vector space and basis of the other using a linear transformation. It was a lot of work. And so now we want to have a bit of fun with it. So we're going to look at linear transformation in Euclidean vector spaces. So in our N with the standard vector operation. All right, so our goal is to study linear transformation on Euclidean vector spaces and link them back to matrices. In a couple of videos ago, we talked about the invertibility theorem, and I said it was a generalization of the one on matrices, but it looked the same, but not clear how matrices link to linear transformation. That's what we'll see now. All right, section 2.3.1, matrix transformation on Euclidean vector space. Right, so a matrix transformation. Let A be an m by n matrix. The function t of A from En to Em, that's going to send an element of, this is Rn, so an element of Rn to A times that element. That's going to give you a new vector of size m. All right, so this is called a matrix transformation. Let's do an example of this. Let's consider the matrix 2, 1, 0, minus 2, minus 1, 3, and I want to see what the linear transformation gives. So TA of x, y, z, we said you just take the matrix and you multiply it by x, y, z, and you get 2x plus y, that's it, and minus 2x minus y plus 3z. All right, so that T of A takes vectors in R3 and sends them in R2. And that makes sense because it's a 2 by 3. That's exactly what we had up in the definition. All right, so these are nice maps. Let's do a different version of this. I'm going to give you a linear map. It sends x, y to minus 2x plus y, y, and 3x minus y. I want to find a matrix so that T equals T of A. So I have minus 2x plus y, y, and 3x minus 6. I want to write this as a matrix times xy. All right, so when I multiply that first row with xy, I want to get minus 2x plus y. So I'm going to multiply x by minus 2, and I'm going to multiply y by 1. So really the entry of your matrix are going to be the coefficient of x and y in this. All right, so for the second row, I want x, and so I don't want to have any y, and I want one x. Oh, sorry, there's a y missing here. And finally, for the bottom row, I want 3x minus 6y, so 3x minus 6y. Right, so my matrix A will be minus 2, 0, 3, 1, 1, minus 6.